Okay, this is video 2 for the Ohm's Law unit notes. In this one, we're going to talk about voltage drops. We can trace the direction that electrons will flow in a circuit by starting at the negative terminal of a battery and then following it through to the positive terminal. Um, that's if that battery is the only source of voltage in the circuit. So remember, when we see the symbol for battery, the longer line is the positive terminal and the shorter line is the negative terminal. So electrons, which are negative, will be repelled. The electrons will be repelled from the negative terminal and be attracted to the positive terminal. So that'd be the path of the electrons. Now from this diagram then, we can see that these electrons are moving counterclockwise from point 4 to point 3 to point 2 to point 1 and then back to point 4 again. So in some ways we can think of a battery as being a pump, but instead of pumping water, it's pumping electrons. Now, as those electrons encounter the 5 ohm resistor, the voltage is dropped across that resistor's ends. The polarity of this voltage drop is negative at point 3 and then positive at point 2, or relative to points 3 and 2. So what we can do is we can mark the polarity of this resistor's voltage drops with these negative and positive symbols, just like I've done here. So in accordance to the direction of the current, whichever end of the resistor the electrons are entering is negative with respect to the end of the resistor that they are exiting. So coming down here again, this side of the battery is positive, this side of the resistor would be considered positive, and if this side of the battery is negative, this side of the resistor would be considered negative. So what we can see then is that, if I were to consider, this isn't a very good way of considering it, but I can kind of consider the voltage traveling this way. And on this side, I have 10 volts kind of, starting at this side of the resistor. And on this side, I would have 0 volts. And then across this resistor, the delta V, or the voltage drop, would be 10 volts. So what this resistor would do is it would drop the voltage by 10 volts. On the battery then, I would say we have our EMF is 10 volts. This is going to become more important when we have more than one resistor inside of a circuit. So as an example, let's say this battery has an EMF of 20 volts. Again, this side's positive, negative. So up here, this would be the positive side of the resistor, negative side of the resistor, positive, negative. So what I can think about is up here, I must have 20 volts entering that top resistor, and at the very, very end, at the end of the last resistor, I must have 20 volts exiting. That way I keep my EMF of 20 volts. So let's say that up here I have 20 volts entering, 15 volts exiting. Here I have 15 volts entering, 0 volts exiting. That means that up here the voltage drop would be 5 volts, and here the voltage drop would be 15 volts. One of the things we're going to learn in a later unit is that all of the voltage drops must add up to give you the EMF of your battery. So obviously here 15 plus 5 gives me my 20. All right, this concludes the unit notes for Ohm's Law.